and ODE. Actually, ultimately PDE you have to convert into ODE. So ODE you will solve with the help of this Laplace transform. So if PD is there, PD you will convert into ODE, then you can solve it. Okay. So advantage is that in the ODE there are some boundary condition given. Okay. So then you have to apply the boundary condition, then you have to find out the constant. But advantage of Laplace transform is that boundary condition will be directly solved in this case. Okay. So you can say that problems are solved directly. Just one formula will be given and your problem will be solved. And in initial conditions also, you can say that initial condition no need to apply separately. Here initial condition will be directly applied. Initial conditions are used directly. So we will solve one problem on that also. With the help of Laplace transform, we will use that. Okay. Many discontinuous function also can be solved. Like Dirac delta function. Or some impulse function. Can be solved directly. So these are the benefits of this, but we will go to directly definition. So there is a pair of Laplace transform. That pair you have to remember. For a function, suppose a function is ft. This is a function ft. Okay. So for this, if you do the Laplace transform, this ultimate Laplace transform, so you will get another function. Suppose that function is fs. So this is correlated. It is a pair. From Laplace, from ft you can get fs if you do the Laplace transform. You can do it inverse also. So inverse also you can do, that is known as inverse Laplace transform. So from that fs you will get again back ft. So that's why this is a Laplace transform pair. Okay, you can get ft to fs, fs to ft. So both way it is working. Note down this.
Sorry.
And Laplace of ft. If you want to find out Laplace of ft, that is equal to fx. So that will be equal to, one formula is there, 0 to infinity, because it was for 0 to infinity limit. ft e to the power minus st. This is e to the power, both function will be there, means both variable will be there, s and t. dt. Here s should be greater than 0. So by using this formula, you can find out any Laplace function. Okay. So let us do some problems. These are just basics only. We will develop that. We will write them directly and we can remember them directly. But whatever the problem come in the NetGate exam, that also we will discuss. So if my ft is equal to 1, so then Laplace of ft will be what? Or you can say Laplace of 1 is what? Or you can say it is fs. So it will be e0 to infinity. In place of ft, I will write 1, then e to the power minus st dt. So you can integrate it. It is e to the power minus st by minus limits 0 to infinity. So it will be 1 by s and minus is inside now. So that's why e to the power 0 will come first. Minus, that minus I am multiplying inside. So minus e to the power minus infinity. So e to the power minus infinity 0 only. E to the power 0 is 1 only. So answer is 1 by s. So you can say Laplace of 1 is equal to 1 by s. So like this you can apply this formula. Note down this.
Sir.
Okay, so next we can do, if ft is equal to e to the power at, so then Laplace of e to the power at you can directly find 0 to infinity e to the power at e to the power minus st dt. Okay, so it will become 0 to infinity e to the power a minus s e dt. Now you can integrate it. A to the power a minus s divided by a minus s 0 to infinity. So if you put it infinity, e to the power minus infinity and minus e to the power 0 and divide by a minus s. So e to the power minus infinity 0. So this is minus 1 by a minus s. It means it will be 1 by s minus a. So hence you can get one direct formula. So Laplace of e to the power at will be 1 upon s minus a. So like this you can find this. Okay, note down this quickly.
Sir.
So this is if ft is sine hyperbolic at. Okay. Now sine hyperbolic at, because I know for the exponential we have done. So sine hyperbolic at I can convert into exponential term. It will be sine at minus 80 divided by 2. So if you want to find sine hyperbolic at, so that will be equal to half of Laplace of e to the power at minus Laplace of e to the power minus at. So like this you can write it. So it will be half of, so Laplace of e to the power at you can write, that is 1 upon s minus a, minus Laplace of e to the power minus at 1 upon s plus a. Now you can take LCM, s plus a minus s plus a, divide by s minus a into s plus a. So s to s cancel, 2 to 2 cancel, it will be a by s square minus a square. Remembering, so this will be the formula. So these all formula you have to remember. So we can write them at one place also. Okay, we will write it, and because in tabular form you can remember them easily. Note down this. So like this you can do for cos also. Okay, so I'm not doing that. You can do that. Laplace of cos hyperbolic at. For that, just here you will put plus. So once you plus, here a will be minus, s will be plus. So it means in the numerator s will be remaining. So that is also very easy. This will be the cos. You can do it by yourself.
Done, sir.
Next question is for if ft is sin 80. Now it will be different, but again sin 80 also can be written in exponential term. It can be written e to the power I80 minus e to the power minus I80 divided by 2i. Okay, so Laplace of sin 80 will be 1 by 2i is common. Laplace of e to the power I80 minus Laplace of e to the power minus I80. So 1 by 2i. Laplace of e to the power I80 will be 1 upon s minus IA minus 1 upon s, it will be s plus IA. Now here also you can take common, it will be s minus IA into s plus IA. So it will be s plus IA minus s plus IA. S to s cancel. So it is 2IA. 2i to 2i cancel. So only a is remaining. So it will be a divided by s square minus IA whole square. Okay. Now I square from here will give you minus, minus, minus will become plus. So it will become a divided by s square plus a square. So Laplace of Sin 80 will be a by s square plus a square. Okay. Similarly, you can do for cos. So this is your homework for cos 80. Now see here, for cos 80, this will be plus and I will not be there. So this will be plus. So once you do this here, due to this plus, it will be s plus ia plus s minus ia. So ia to ia will be cancelled. In numerator it will be 2s. In denominator it will be 2i. So 2 to 2 cancel. So only s will be left. So it will be s divided by s square plus a square. And now because see this is plus, so there is no problem. But in hyperbolic now, one more condition will be there. In hyperbolic, because denominator we have minus term. So if s should be greater than a, this should be the condition. If s is less than a, so that time it will become minus. Okay, so this is also the condition here, that s should be greater than a. So note down this also.
Done, sir.
Okay, so two more are left. If ft is t to the power n, okay, so then Laplace of t to the power n will be integral 0 to infinity t to the power n e to the power minus st dt. So this is directly a gamma function that we have done many times. Direct formula for that is gamma n plus 1 divided by this, whatever is this, that to the power n plus 1. So this is the formula for this. Okay, so you can say this in this form also. Gamma n plus 1 is factorial n divided by s to the power n plus 1. So both the formula you can remember. So Laplace of t to the power n will be, either you remember gamma n plus 1 divided by s to the power n plus 1, or you can remember factorial n divided by s to the power n plus 1. Okay, note down this.
Done, sir.
Next is unit step function. What is the meaning of unit step function? It is having the steps. and whenever it get the step, its value become unit. So such function is known as unit step function. So at some time, at some point only it will have a step. Suppose this is having a step here at x equal to a, or don't take x because here we are taking our function is t na. So t you take at t equal to a. At t equal to a, it will have a step, and that step value is 1. So this is a step. But once it is not said anything, so it will going continue with this step only. This is 0 point. So at point a, t equal to a, it will get a step value is unit. So that's why this function is known as unit step function. Now this step also can be at 0. So it will start from 0 at that point. Okay. So because it is starting at a, so that point you will write as, this function you will write as u t minus a. If I am saying you step function u starting at 0, so then that function will be ut. So then it will start from here only. So this is a unit step function, but it is starting from 0. So this is known as, either you write it t minus 0 or it is a ut. So these are known as step function, and this function is u t minus a, because this, whatever this point you put it equal to 0. So it means t is equal to a. So your point is t equal to a where it is defined. Okay. Now for this type of function, ut minus a is this one. This you remember. So for this type of function, if you want to find out the Laplace of that, so Laplace of t minus a will be equal to integral of 0 to u t minus a into e to the power minus st dt. Now, actually this function have two values now. Tell me, this function between 0 to a, there is a different value, and between a to infinity, there is a different value. It means my integral will be break into two type. One break will be 0 to a, ut minus a, e to the power minus st dt, plus a to infinity, it is having different behavior, ut minus a, e to the power minus st dt. Now tell me what to take this function between 0 to a. So between 0 to a, this value is 0. So it will be bigger 0. Now between a to infinity, this value is constant, that is 1. So that you can put a to infinity value is 1 into e to the power minus st dt. So now you can integrate this. So it will be e to the power minus st by minus s, limits are 0 to infinity. So note down this first.
Done, sir.
Now minus 1 by s, it will be minus e to the power minus infinity minus e to the power a. S is also there, no? Means in place of t I am writing a. So it will give you 0, minus 2 minus plus, so answer is e to the power as by s. So you can say Laplace of unit function t minus a is equal to e to the power as by s. Okay, so you note down quickly, then I will make a table. In that table, everything will be at one place. Done?
Yes, sir.
So you can make a table. Here you can write ft. Here you can write fs. In this table, number 1, ft is 1. So then what was the answer? 1 by s. ft is e to the power at. So answer was 1 upon s minus a. Here condition is that because this complete thing should be positive, so s should be greater than a. Then we have done sine hyperbolic at. For that, a divided by s square minus a square. Here also s should be greater than a. Number 4, I told you that you can solve the cos hyperbolic at. So in cos hyperbolic at, in the numerator s will be there. So it will be s upon s square minus a square. Here also s greater than a. Now next level comes number 5, sin 80. So for sin 80 it was a upon s square plus a square. Now both the things are positive here, so no need to write s greater than a. Cos hyperbolic 80 s upon s square plus a square. Similarly, you can write t to the power n. So for that you can write, either you write factorial n divided by s to the power n plus 1 or gamma n plus 1 divided by s to the power n plus 1. And next is unit step function ut minus a. For that we have find out it is e to the power minus as divided by s. It is minus as.
Plus s.
It is plus as.
Mistake. Minus will come, right?
Minus st na, so you put a, so it will be minus s. Correct it. So this will be your complete table. Now both way it will work. If Fourier Laplace you want to convert, that also you can use. This is your Laplace transform. if inverse Laplace transform you can convert, so that time also this table will work. You see the right hand side, from there you can get the inverse Laplace transform. So you can say that it is Laplace inverse of 1 by s will be equal to 1. Laplace inverse of 1 upon s minus a will be equal to e to the power at. So like this you can get Laplace inverse of everything. Understood? So this way also this table will work. So you can note down this quickly.
Sir, if s is less than a, then the Laplace transform does not exist.
Yes, this formula will not be valid because negative value it will come, no?
Yes, sir. The integral will go to infinity.
Yes, negative will should not be there.
Sir.
So note down this also. Now we can do some problems. Suppose question is, first I will do easy. When practice is made, then we will go to tough. So this is the question. Find Laplace inverse of s plus 2. Okay. So this I can write Laplace inverse of s, because my formula is for s minus a. S minus 2 I can write. So this will work as a. So Laplace inverse of s minus a. Now you can check the same table for both. Laplace inverse for s minus a. So this is s minus a. Laplace inverse of that will be e to the power at. Now a is minus 2. Like this you can do. A is minus 2. So answer will be e to the power minus 2t. So that will be answer here because a is minus 2. Similarly, one more question. These are basic questions. Find Laplace inverse of t to the power 2. Now here n is equal to 2. Sorry, this is for Laplace. N is equal to 2. So what I told you formula, gamma n plus 1 by s to the power n plus 1. So, or you can say it is factorial n divided by s to the power n plus 1. So a factorial n is 2 only. Then s to the power n plus 1 means 3. So 2 by s cube will be the answer. Okay. Now if someone asks you what is Laplace inverse of 2 by s cube, so that answer will be t square. From here you get the idea that also should be in the numerator. If someone asks you what is Laplace inverse of 1 by s cube, because you know that this much you should guess that how it can be solved. So because 2 by s cube we give you t square, so 2 is not there, so you can take 1 by 2 here and 2 here, then it will be solved. So then answer will be 1 by 2 t square. Like that you can do if Laplace inverse of 1 by s cube is asked. So little bit adding, multiplying and division or differentiation or integration. So little bit that much skill you should develop by practicing these problems. Okay. Only that skill they want to check in exam. Simple formula will not be there. Some skill should be there to make it in that simple formula, then you can convert in answer. Done?
Sir.
Now there is one shifting theorem. So in the shifting theorem, one function will be shift and you will get different answer. Suppose if Laplace of ft, because you know it directly, that is fs, that you know already. Then Laplace of, if some exponential term is there with the ft only. Okay, and formula for ft you know. If extra term is e to the power at, so that can be solved easily. Directly you take fs, in fs you replace f s minus a. This e to the power at, just s will be changed by s minus a and answer is same. So like this you can do. Okay, so we can see the example for that. If ft is 1, okay, so Laplace of e to the power at into ft is equal to, and we know the Laplace of 1 is 1 by s. So Laplace of e to the power at ft will be f of s minus a. Okay, now because your ft is 1, so Laplace of e to the power at will be, you can say this is into 1, so that will be 1 by s. We already know this. So 1 by s, in that you put s minus a, and that is true. Laplace of e to the power at, already we have proved that it is 1 minus s by a. So like this theorem is true. So similarly, we can take another question. First note down this quickly.
One sir.
Okay. Find Laplace of e to the power minus 2t into t square. Can you solve this question? Okay, all of you solve, please tell me answer. All of you solve it quickly.
So 2 by s plus 2 whole cube.
2 by s plus 2
Cube.
Anybody else?
Yes, sir. 2 by s plus 2 to the power whole cube.
Same na?
Yes, sir.
Okay. So how we can do this? Because you have to know here, because Laplace of t square is how much?
2 by s cube.
Now we have done 2 by s cube. This we know. So now Laplace of e to the power minus at into ft means here a value is minus 2 and s minus a you have to do. So it will be s s minus minus 2 whole cube. So answer will be like this. You can do it. Okay. Now, if someone asks you again the same thing, means shifting problem also work for inverse Laplace transform. So inverse Laplace transform of 2 by s plus 2 whole cube is what? So for that also, first you have to see inverse Laplace transform of 2 by s cube. So what is that? That is t square. So in that, if this is s plus 2, it means exponential term you have to multiply. So then by shifting theorem, Laplace inverse of 2 by s plus 2 whole cube will be just e to the power minus 2t you have to add in that. So this will work for inverse Laplace transform also. So only practice will make you to understand everything. Now one more question is there. Okay, note down this.
Then, sir.
Laplace of e to the power at cos bt. So this you have to find. Okay. So then if you know the formula of this, in that you can put minus a extra. That's it. In place of s, you have to put s minus a. So because we know that Laplace of cos bt is s divided by s square plus b square. Okay. So in this, so Laplace of e to the power at cos bt, by using the shifting theorem, it will be s minus a divided by s minus a whole square plus b square. Okay. So like this you can do. Now I will take one net example, net question. So this question is, if fs is 3s minus 137 divided by s square plus 2s plus 401, find ft is what? So this was a net question of 5 marks. Can you solve this by using the same method? You try it. Okay. Because this type of problem will come in the exam, so you have to fight with such problem. If you are fighting, no problem, I will tell you if you are not able to get the answer, but solve this and tell me the answer. Anybody getting answer?
So 3 e to the power minus t. Actually, I'm getting s plus 20 and is it like that? So b is 20 minus 20.
That is also the portion, but
so the numerator is having some difficulty.
Okay. So this type of question come in the exam. Okay. So whatever we have done up to here, that was just basic for this type of problem. So this we have to learn. Anybody else facing any problem? No?
Yes, sir. The last part, like I have factorized it like the denominator s minus 21 whole square into s plus 19 whole square. But after that, I'm not.
Okay, so leave it, no problem. So you have to learn the trick here, how to find out that, because your Fs is 3s minus 137 divided by s square plus 2s plus 401. Okay, so see my formula, remember in mind your formula also. One formula is for a by s square plus a square, another formula is for s by s square plus a square. So a by s square by plus a square is for sine, s by s square plus a square is for cos. So I want to convert in that form that I need. So how I can do it? First of all, what can be made from here? So that it is s square plus a square kind of thing. Now I know that 401 is not a square term, but if take here away 1 from here, so then it will become 400. So then it will become a square term. So attack on that first. So this whole will become 3s minus 137 divided by, this will become s square plus 2s plus 1 I am taking away and plus 400. So this 400 will be working as 20 square and this whole term will be working as s plus 1 whole square. So now it has become in the square terms. So it will be written as 3s minus 137 divided by s plus 1 whole square plus 20 whole square. Okay, so it is going towards that formula only sine and cos, but s plus 1 is there. So in numerator also I must make s plus 1. So it will become 3s plus 1 if I make it. So then 3 I have to subtract from here. Then it will be 1 minus 137 divided by s plus 1 whole square plus 20 whole square. So it will be 3 into s plus 1 divided by s plus 1 whole square plus 20 square. Okay, and minus this minus 3 and minus 137, it is 140 into 1 divided by s plus 1 whole square plus 20 square. Okay, now these 3 and 140 are constant. Just we have to check these. Now check here, because Laplace of cos 80 is equal to s divided by s square plus a square. So in that if you compare Laplace of some e to the power suppose e to the power bt into cos 80, so that will be what? S minus b divided by s minus b whole square plus a square. So like this you can think. So now here it is s plus a, so it means minus will be there. So it will become 3 into e to the power minus t into rest all, it will work as cos. A value is here 20. Like this you can convert now. Minus 140 into, so this will work as sine, it will work as, but s plus a is there, so e to the power minus t into sine of 20t. Now tell me, can you do this or not?
Sir, clear this as a is equal to minus 1.
Sorry. Here we have to take 20. A divided by that we have to, so it will be 20. So it is 7 only. Yes, tell me, what is your question?
Sir, b is minus 1 then. A we took 20 and b minus 1.
Yes. So this type of question you practice, whatever you found in the old year papers. If you practice, then only you will get the skill, how to get the answer. So in such type of problem now, first you have to anticipate, you have to think what you can do, then only you have to arrange likewise. So first anticipate and then arrange likewise, then only you can solve such type of problem. Because direct formula based question doesn't come, but it is based on that only. Here sine formula, which one use? Sin at equal to a divided by s square plus a square. So that formula we apply. And because it is s plus 1, so e to the power minus 80 will also come, minus 1t.
Done, sir.
Okay, but sometimes this answer, again I'm telling you, sometimes this answer is not in this form. Then you will say that in the option no answer is available. Sometimes they may ask you in the graphical form. So that a skill also you should have. Suppose it is a graphical form, ft t. So now how this is changing? This you can take. Here ft is e to the power minus t, you can take common because it is same here. So this is 3 cos 20t minus 7 sin 20t. Okay, so in this first of all you have to check at 0 level, because you have to recognize 4 option. In the 4 option graph you have to recognize. First of all you should think that cos and sin term are there, so your curve will be oscillating. Oscillating means up down it will go. But at t equal to 0, what is the condition of that? That you have to check. So put here t equal to 0, e to the power 0 is 1, cos t will be 3 only, because cos 0 is 1, sin 0 is 0, so it will be 3. So start from 3. Your curve start from 3 and it will be a oscillatory form. Like this it will be. Okay. So this much skill you should have. Just only you have to check. Just put t equal to 0, answer is 3, so it will start from 3. And because cos sign are there, so it will be oscillating, so you oscillate it. That's it. Okay. So this is just single step ahead, whatever you get in the answer. And many times they do it. If some difficult curve are there now, you want to test them. Okay. So there is a Desmos. You can have this application on your mobile. Okay, so this is a mobile app. You can put your equation in that, then you will get a curve. So this is to check whether you are doing good or not. So it will be around that only. Desmos app. You know it or not?
Don't know, sir.
Okay, so in mobile today you can fit it. So wherever you find some equation, you can fit that. You just type that equation and how it will give you the curve, you can match. Okay, so just to get the idea for difficult equations. Now let me take one more question. Laplace of a minus bt whole square. So it is a simple question. Just a square plus b square t square minus 2ab into t. So then it will be a square into Laplace of 1 plus b square into Laplace of t square minus 2ab into Laplace of t. Like this. So now a square into Laplace of 1 is 1 by s, b square into Laplace of t square means factorial 2 divided by s to the power 2 plus 1 means 3 minus 2ab into Laplace of t is factorial 1 is 1 divided by s to the power 2. So like this you can get answer. Okay, note down this.
Answer.
Okay, you solve this problem. Find out Laplace of cos square omega t.
Sir, 1 by 2s plus s by 2 into s square plus 4 omega square.
1 by 2,
1 by
1
s
by
plus
s plus s.
s square plus 4 omega square.
Okay, so everybody is getting this.
Yes, sir.
Okay, so quickly you can see thus this cos square omega t I can write 1 by 2 of 2 cos square omega t. So Laplace of 1 by 2 will be here. Laplace of 2 cos square omega t we can write 1 plus cos 2 omega t, and here a will be working as 2 omega. This Laplace of 1 is 1 by s, and cos 2 omega t s by s square plus a square. A square is this, 1 by 2 is this. Like this you can get. Okay, now one more question. Laplace of e to the power minus t sine hyperbolic 4t. So what I told you in this type of question, this is a shifting problem. So here write this value Laplace of sine hyperbolic 4t, and in that put s equal to s minus a, and a is already minus 1, so that will become s plus a. So you have to write this. This is 4 divided by s square minus 16, but this s you have to replace by s minus 1, sorry, s minus minus 1, so that will be s plus 1, so it will become s plus 1 whole square. Okay, so now this much of a skill you have, you can do all the problems. Okay, so means question can become some little formula will be there, some shifting problem will be there, and after that they need answer. Direct formula will not be there. Suppose there is a different question, cos omega t plus theta. So here also you can open it, cos omega t cos theta minus sin omega t sin theta. So you can apply now, but cos theta is constant. Only on t it will be applied. Only on t it will be applied. This will be constant. So it will be cos theta into s divided by s square plus omega square minus sin omega t into a. Because in sin omega t, a is omega by s square plus omega square. So this will be the answer. So note down this quickly. So now I will take different variety.
Sir.
Now, sometimes the question itself can be in graph. Find the Laplace of function, and this function is given to you like this. This is ft, this is t, and this is a line this. Okay, here it is touching at 1, here also it is touching at 1. Now tell me, where is the function? So this is your function, ft, and ft will be how much here? Now please tell me.
1 minus t.
1 minus t. Very good. Okay, so this is the function here. Now everybody know this, how to find out this function, or should I tell? Manjunath,
Sir.
you know how to find out this?
Sir.
Sanjukta, Sambanthi, all you know?
Sir.
Yes, sir. This simple one we know, but the difficult one, please tell one.
Actually, in this type, what you have to find? Miss, first of all, you know the equation y equal to mx plus c. Okay, so m is your gradient that you have to find. Now gradient, it is going down, it is -1. So I will tell you how to find gradient. So gradient, how to find you? M equal to y2 minus y1 divided by x2 minus x1. So here this is 1 0. So this is your x1 y1, and this is your 0 1. So this is your x2 y2. Second point. Okay, first point on x-axis, second on y-axis, like this. So you put it here. So y2 minus y1. y2 is 1 minus y1 is 0 divided by x2 minus x1. x2 is 0 minus x1 is x1 is 1, x2 is 0. So answer is -1. So this is your this. Now C is what? Intercept on y-axis. So intercept on y-axis, it is getting at 1. So that is equal to 1. So C is equal to 1. So y will be, y is your ft. ft will be minus of mx. In place of x, we are using t. So minus t and plus 1. So this will be the function. So basic thing you have to apply, then you can get. So it is 1 minus t. So for that, you have to find out the. Now tell me, what is the Laplace of this? Can anybody do? Tell me this answer.
1 by s minus 1 by s square.
No, wrong. Here,
Shifting.
huh?
Will be shifting there.
No. Here limits are 0 to 1, not 0 to infinity. Okay, so that is also a point. So Laplace of ft is equal to 0 to infinity minus e to the power minus st ft dt. This was my formula. But my limit are 0 to 1 only. Here limits are 0 to 1 only for t. 0 to 1. This was the formula, no? So ft is what? Ft I will put 1 minus t into e to the power minus st into dt. So this is the problem. So this you have to integrate. Okay. So note down this first quickly. Okay. So how to integrate it? So this is the first function, second function. So first function as such into integration of second function e to the power minus st divided by minus s. Then minus of differentiation of first function is -1 into double integration of this minus st by minus s whole square. Now limits are 0 to 1. So now first you put 1, t equal to 1. So this term will become 0. It will become minus minus plus, and 1 by s square is also there into e to the power minus s. So this is for 1. Now minus, once you put t equal to 0, so this will become -1, and again minus s is there. So it will become 1 by s, and e to the power 0 is 1. Now minus minus already it was plus, so due to this it will be minus e to the power 0 is 1, and 1 by s square already there. So this is the answer. So Laplace of ft will be 1 by s minus 1 by s square and plus 1 by s square e to the power minus s. Okay, so this is a very good question. Note down this. Done.
Yes, sir.
So these graphical questions are also very important. One more question I will give you. If or you can say directly, find the Laplace transform of a function So only this much is given. You have to find out the Laplace function of this. Now, can you convert this into function? Can you convert this graph into function? Any idea?
Sir, using two-step functions.
Using two-step function or two-unit function.
Okay, sir.
Okay. You see here. Suppose I have a function like this. It is going to infinity. I have another function like this. Like this. Okay. It is going to infinity. This is also going to infinity. So this is at point A. This is at point B. Now in place of unit, he is saying that this value is K. In place of unit, he is saying that this value is K. So can you name this function?
K into f of t minus a.
K
Unit
into
function, but u of t
ut minus a. Ut minus a was my unit function. But here value is K. So multiply by K. And can you name this function? K into u t minus b. Now tell me, if I subtract from k u t minus a, from there I subtract this, so it means it will this point is b. So if I subtract from here to here, so this portion will be cut. Okay, this further portion will be cut and only this portion is left. And this is that. Understood this?
Yes, sir.
So like this skill you should have, then only you can solve such type of problem. So these are difficult problems, no problem. Okay, so you must learn this. So here what I am doing, so ultimately this function will be ft equal to k into u t minus a minus u t minus b. Okay, so this type of logic if you apply, then only you can solve this problem. So now Laplace of ft will be Laplace of k into u t minus a minus u t minus b. Now k will come out. You have to find Laplace of u t minus a minus Laplace of u t minus b. Now formula I told you, we have proved today only. K into Laplace of u t minus a was e to the power minus as divided by s, and minus e to the power minus bs and divided by s. Okay, so this is the answer. Note down this.
Done, sir.
Okay, so next question we can take. Find inverse Laplace of Fs equal to 0.2s plus 1.8 divided by s square plus 3.24. Okay, so can you find this? Find out this, please tell answer.
Sir, 0.2 cos 1.8 t plus sin 1.8 t.
Yes. If you do the square of this now, that will be 3.24. So from here only you will get clue. So it is 0.2s by s square plus 1.8 whole square. So this will be working as a, and plus 1.8 divided by s square plus 1.8 whole square. So this is 0.2 is a constant, otherwise it is s by s square plus a square. So this is cos, and 0 point is already there, cos 1.8 t, and plus this is sine 1.8 t. Like this you can solve. Okay, now one more variety of question you will see. Suppose find inverse Laplace transform of Fs equal to this. I am giving you simpler one, you can practice with that. Okay, this type of question you will see. Now here partial fraction you must know in such type of problem. Okay, so if you want to solve such type of problem, so you have to put, this is simpler one. If some square is there, then you have to take in numerator ax plus b like this. Okay. This is s plus a into x plus b, that you will use the partial fraction method. So a by s plus a into plus b by s plus b. If some one of them is square now, so then you can take here a s plus b, means two coefficient will be here only, and if it is single, then it is single coefficient. Like this you can choose. Okay, so then multiply on both sides with this, so then it will become 1 equal to a into s plus b and plus b into s plus a. Now you can multiply this, so 1 will be as and bs is there, so a plus b into s, and plus ab and ba is there, so that will be ab plus ba. Now both sides you can compare the coefficient of s to the power 1, s to the power 0. So a plus b will be 0. Comparing both sides, coefficient of s to the power 0, s to the power 1, you will find that a plus b is equal to 0. So from here you will get a equal to minus b, and this ab plus ba is equal to 0. So here you can put that value. Okay, so then you will find a equal to 1 upon b minus a. So these value you will put here, then you find the Laplace inverse of this, Laplace inverse of this. So note down this. So this is the method we will apply.
Done, sir.
So your fs will become now this. So fs will be a value is 1 upon b minus a into 1 upon s plus a, and minus of 1 upon b minus a and 1 upon s plus p. So now you can find out Laplace inverse. Okay, so Laplace inverse will be ft. Laplace inverse of this fs will be 1 upon b minus a into Laplace inverse of 1 upon s plus a is e to the power minus at minus e to the power minus bt. So this will be the answer. If you want to keep it a minus b, so then they will be revert. So like this you will get the answer. Okay, so note down this also, then we will go to different variety.
Done, sir.
Okay, next is the Laplace transform of derivatives. And integrals. Okay. If Laplace transform of ft is equal to capital Fs, this you must know that capital F I am using for Laplace transform value and small f I am using for given function. Okay. So Laplace transform of f, it is dash actually, 1 dash 2 dash 3 dash, it is nth dash. It means it is nth derivative. F to the power n means nth derivative, because we are solving for derivative. If you find some derivative of a function, so Laplace transform of that will be equal to, there will be a formula that s to the power n, this is the product of answer. So s to the power n into fs. Fs means whatever the Laplace of ft was there, that you will write as such. Okay, s to the power n fs minus, then you reduce this s to the power in every term. So then it will be s to the power n minus 1 into, here start from 0 means start from without differentiation. So this small f is your function. This you mind it. This is your function at t equal to 0. And this is your Laplace of function. So don't be confused here. This capital F is Laplace of function. Means from answer I will take it. And this function is just directly I will take it. So you put here f0. Now next term, in next term you put s to the power n minus 2. Next it will be f dash. Now this dash will increase. N will reduce, dash will increase. 0. Next term minus s to the power n minus 3 into f double dash 0. So like this I will go on. The second last term will be here s, because by reducing it will be remaining s. So then f will be n minus 2. It is increasing, but at t equal to 0. And at the last term, this s will not be there because it is s to the power 0, but f will be n minus 1. Understood? So this is the complete formula for this, but this complete will not be coming in the question. Maximum they will give you double differences. That's it. Okay. So if they are asking you double differentiation, suppose this is the question. So Laplace of f2t will be what? So you apply here and you can get it. So n is 2 here. So it will be s square fs minus, here s to the power n minus 1 means 2 minus 1, that is s f0, and minus, now it has become the last term, that's it, f dash 0. So if Laplace of double derivative is there, so that you can remember it, s square fs minus s f0 and minus f dash 0, that's it. So like this you can find out. Okay. Now if I am giving you this question, find Laplace of cos at double derivative. Not, it is not a square, it is double derivative, or like this I can write d2 by dt square of cos at. Now tell me, can you get the answer? See, Laplace of ft I have to find first. Here Laplace of cos 80 it is. Laplace of cos 80 will be s divided by s square plus a square. This you know. So here what you have to do, because this is a double method, so here you have to apply s square fs minus s small f0 minus f dash 0. So now put value s square into fs is what? Fs is this s upon s square plus a square minus s into a small f0 is what? This is your ft cos 80. Here you put 0. So cos 0 is 1. So this is s only. And minus f dash 0. So f dash will be a sin 80 minus a sin 80. So that will become plus a, and in sin 80 you will write t equal to 0. So that will become 0. Okay. So complete answer is this much only. Note down this.
Yes, sir.
Okay. Okay, see, if suppose this is f dash f1t, so now what will be the formula? It will be s fs and minus directly f0. That's it. For f1t it will be sfs minus f0. If you find somewhere that different single differentiation is there, so then you can solve like this, sfs minus f0. So suppose I am giving you the question, find Laplace of dy dt of cos 80. So this formula you will use, sfs minus f0. Now you can put the answer, s, it will be s into s by s square plus a square, and minus f0 is what? F0 in direct you have to put, not f dash, in direct you have to put. So this is ft is cos 80. So cos 0 is 1. So answer is 1. So this will be the answer. Note down this. You can simplify it more because answer can be in some other form. This s square plus a square, you can take LCM. So it will be s square, because s into s is s square, minus s square minus a square divided by s square plus a square. So this to this cancel. So answer is minus of a square divided by s square plus a square. Okay, note down this. Done?
Yes, sir.
Okay. Next is integral part. if Laplace of ft is fs, then Laplace of integral 0 to t ft dt will be equal to just 1 by s you have to put into fs. Okay. So similarly, if you want to find out, suppose if this is my question, if ft is cos pi t, then find Laplace of integral 0 to t cos pi t dt. So this you have to find. So by using this method, you can do here Laplace of cos pi t will be s divided by s square plus pi square. Okay. So in that you can do, so Laplace of integral 0 to t cos pi t dt. So just what you have to do, if single integration is there, so 1 by s you can multiply in that answer, in that fs. So s square plus pi square. So s to s cancel. So answer will be 1 by s square plus pi square. So like this you can do. And inverse transform also you can do. So inverse transform, to get the inverse transform, inverse Laplace transform also you can do. You have to create 1 by s, then you can convert in this. So note it down. Done?
Done, sir.
Okay. One more question can come. Laplace transform of Dirac delta. Dirac delta function. So in this, what I will tell you, just you use the formula. So formula is integral 0 to infinity e to the power minus st into ft dt. This was our formula. So just you put ft. Ft is delta t minus a dt. Okay. Now this is the property of Dirac delta. If this point, so point here is a. To get point, put this everything 0, t minus a equal to 0. So t equal to a is point. So if this point a belong inside the limit, so limits are 0 to infinity. So a value is any constant. This is positive. So definitely it will be in between 0 to infinity. So if it is in between 0 to infinity, so then whatever your function, other function is there, just replace t by a. Just replace t by a. So then that will be your answer. It means that will be e to the power minus s into a. If it is not between, if this exists, then integral will be fa. Whatever the function is there, in that you put a. If not, then integral will be 0. If not means if it is outside from that, if suppose a is minus a, so then minus a is not in between 0 to infinity, so then that answer will be 0. So like this is the property of delta, Kronecker delta. Sorry, this Dirac delta. Note down this. Done?
Yes, sir.
Okay. Now quickly we will see a problem is find inverse Laplace transform of 1 by s into s minus a. Okay. So I told you this, if 1 by s is there, so then you have to integrate. So Laplace inverse of 1 by s into 1 by s plus a. Inverse of s by Laplace inverse of s plus a, you know. Sorry, it is minus now. What is Laplace inverse of 1 upon s minus a?
E to the power 80.
E to the power 80. So just integrate that 0 to t dt because 1 by s is there. This only we have learned now. By this property. If ft is there, so ft is e to the power 80. If integral of that is there, so 1 by s you have to multiply. So inverse, in inverse 1 by s is there, so one time you have to integrate. If 1 by s square is there, two time you have to integrate. So this thing you must learn. So here also I can write one more problem. Laplace of, this is n time, 0 to t, 0 to t, 0 to t. If it is n time integration is there, ft dt n times. So that you can take 1 by s to the power n fs. So with that property, if I am asking you another question, Laplace inverse of 1 upon s square s minus a. So it means what? You have to do double integration of 0 to t, 0 to t, e to the power 80 dt. Okay, so like this you can solve it. Okay, one more net question I will take. You note down this quickly. Done?
Sir,
Yes.
if we do it, we will just get 1 by a square. But we have to put the limit and it will change on the right hand side when we evaluate the integral.
No. 1 by s square, Laplace inverse of 1 by s square, 1 by s minus a. We can write Laplace inverse of 1 by s into 1 by s. 1 by s minus a. Okay. So you can apply on this. This thing you can take as single. So it will be Laplace inverse of 1 by s of single is integral 0 to t, and again on that also you can apply one time. So two time it will be now. You can do it like this.
Yes, sir.
Okay. Two time you have to apply. and I will give you the answer. Okay, you can do it. Otherwise, it will take time. Just integration e to the power at divided by a. In that you put 0 to t. So that will be e to the power at minus 1 divided by a. Again, that you have to integrate. You can do it. Is it easy?
Yes, sir.
Okay. So now, very beautiful question. It is a net question. Find Laplace inverse of 3s plus 4 divided by s to the power 4 plus k square s square. So this is a question. So here you can anticipate what I can do. So what you can do, because now you have learned 1 by s square method also. If 1 by s square is somewhere, you can do double integration. So here it is Laplace inverse of or simply fs you arrange first. Fs is 3s plus 4 divided by, here 1 by s square I can take common. So it has become integral type of question. So 3s plus 4 divided by s square plus k square it has left. So now it is very simple. So it is 1 by s square into 3s by s square plus k square and plus 4 by s square plus k square. But here I need k, and so I will divide by k. So this will be like this. So now I can take the Laplace inverse. So Laplace inverse of, so 1 by s square means double integration I have to take. So directly I will write ft. So ft will be integral 0 to t and dt. So this is for 1s. Again it is integral 0 to t dt for second s, because this is 1 by s square. So in that you keep all this function. Okay. So this is 3 into. Now tell me what is the ft for that. This integral part I have done, just ft part I have to put here. So ft part for s by s square plus k square will be cos of kt. Understood? Plus this is 4 by k now, and from here ft part will be what? K by s square plus k square. It will give me sine of kt. Now you integrate it, put the limit, again you integrate that, put the limit. So this is your homework. You can do it. Okay. So this is a net question of 5 marks. You can get the answer. Note down this.
Done, sir.
Okay, one more variety I will take. I told you initially that we can solve the partial differential equation and ordinary differential equation with this. That is known as initial, and boundary condition also will be there. But no need to use boundary condition. Directly we will solve the problem. Suppose this is ODE. I am taking ordinary differential equation. Okay. Question is solve just simpler one I am taking so that you can understand the method. Dy by dt plus ay is equal to e to the power minus bt. So this is non-homogeneous equation. Okay. So here initial condition is, one second. Hello. हाँ बोलो. हाँ नहीं आइटम लेके आए या फिर ओके ठीक. Okay. So this is d by dt plus ay and initial condition is given. So you can do it by ordinary differential method also, no problem. But this also can be applied, that I want to show. Okay. And question is find yt. So this solution you have to do. So to apply here Laplace equation, because we know Laplace of differentiation, we know the formula, so that we can apply here. So you take it, let Laplace of y is ys. Okay. Or you can take fs if you are confused. Because here my function is y. Understood? Function is not ft, function is y. So Laplace of y is suppose fs, same type I am taking. Okay. So taking Laplace of this complete equation 1. If I am taking Laplace of complete equation 1, so because this is differentiation, for the differentiation formula is what? This is single differentiation, s into fs and minus f0. So f is what here? Y. So minus y into y0. So this is the Laplace of this dy by dt and plus Laplace of ay, is constant, Laplace of y is fs. That will be equal to, now Laplace of e to the power minus bt is 1 upon s plus b. Okay. But I want to know first this fs. Then I will take, or you can say, whatever the fs is there. So this implies that Laplace inverse of fs is your yt. And this is you want to know. So find segregate fs from here and then take the Laplace inverse of that. So here fs, here also you can take common. So fs into s plus a it will be, and minus this limit already they have given, y0 is 0. So this term is 0. So leave it. So that is equal to 1 upon s plus b. So this implies fs is 1 upon s plus a, s plus b. Okay. So yt will be Laplace inverse of fs. So Laplace inverse of fs, 1 upon s plus a, 1 upon s plus b, that I have done just now. I will not do it again.
1 by a minus b, the e to the power minus bt minus that.
Where was that? Yes. No. Yes, it is 1 upon a minus b e to the power minus bt minus e to the power minus at. So this one. So this is 1 upon a minus b e to the power minus bt minus e to the power minus at. So like this you can do. Note down this. Okay, so initial condition, they have been used directly. You no need to apply separately. Directly they have been used and you will get the answer directly. So that only I told in the first advantage of Laplace. Okay.
Done, sir.
Okay, so one more question I will give you, that is totally different question, but it will give you too much insight. You will realize something. The question is, find qt and it in the following circuit diagram. This is a electronics and totally it will be solved by Laplace. You will see magic. Okay, so this is your source. So at this source, suppose this is your ft. Sorry, okay. Actually here delta t is given. This is a this is a function of t, okay, function of time. Now with the time, actually what happened here, this is a voltage, this total is a voltage, this total voltage will be divided into these three parts. Okay, so this is my inductor. In that inductor L, your VL will be what? VL will be L di by dt. Okay, so this is a drop here. Now because we know I is already dq by dt, so if you put it here, it will become L d2q by dt square. So first of all this. Now second thing, this is a capacitor. In capacitor, what is the voltage drop? That will be q by c. Done. Third is your here at the resistance. At the resistance, VR is how much? I into R. I is already dq by dt into R. Okay, so these are the this is the drop. Suppose the total source voltage was delta t. Now it is divided into three drops. This is drop, this is drop, this is a drop. Hence we can write, so we get a equation, but before the equation I want to tell you the value of L. Value of L is 1 Henry. In MKS only these limits are written. Value of R is 20 ohm. Value of capacitance is 10 to the power minus 4 farad. Okay, so this V by C will be how much? Q by C. C is 10 to the power minus 4. So that will be 10,000 into Q. That you have to use this value. and here this is r into dq by dt, 20 into dq by dt you have to use, and this is L is 1 only, so that will be 1. So that will be d2q by dt square. Okay, so we get a equation that this delta t value will be running, and it is equal to d2q by dt square plus 20 dq by dt plus 10,000 q. So this has become equal to this. So this is a second order differential equation, and it can be solved by the Laplace. So note down this first.
There will be just minus for the inductor, voltage in inductor.
Huh?
The V in inductor.
No. I'm showing you that it is a drop. These all are impedance only, na? So they will waste this. They will waste this voltage. So these all are drop.
Then sir,
So here source is given. Source is Dirac delta function. So source is your Dirac delta function. Okay. So now what is our method? Take Laplace of both everything. So here suppose Laplace of this q is equal to fs, same thing I can take. So take Laplace of equation. Now it is double differentiation. In double differentiation also I told you the formula. S square into fs will be first term minus s into function at 0 point. So q0 will be there and minus q dash 0 also will be there. So this is from this term. Now plus this is first derivative. So here also 20 into s into fs and minus q0 will be there from here. Okay, understood? This formula we have done already, and plus Laplace of this. So this will be 10,000 fs, that is equal to 0. Okay, now here actually some conditions are also given, so those also you have to write. Conditions are q0 is equal to 0 and q dash 0 is also 0. So these are the conditions. These are also given. So once you put that, so this also will be 0, this also will be 0, and this also will be 0. So what is left in this equation? S square fs plus 20s fs and plus 10,000 fs, and that is equal to not 0, actually it is Laplace of Dirac delta function t. Okay, so this will be equal to, now Laplace of Dirac delta function t, I told you how to solve this. Integral 0 to infinity e to the power minus st into Dirac delta t. So actually if nothing is there, if it is t minus a, then point will be a, If it is nothing is there, so we can write it t minus 0. So 0 is also in between 0 to infinity. So then the answer will be f0. So f0 is e to the power 0, and that is 1. Okay. So from here, if you take fs common, so fs will be 1 divided by s square plus 20s plus 10,000. Okay. So now I can solve this problem because s square plus 20s, with that if I write 100, so then it will become a square term, s plus 10 to the power whole square, it will be because I want to solve the inverse of s I want to take. So fs I can convert s plus 10 whole square. You can do it. So 100, because you have taken 100 here, so what is left here? 9900, because 100 we have taken here. Okay. Now this 9900 is approximately a square of 99.5. Okay. So this question has become now in terms of sign, but if I take 99.5 above also in the numerator, so it will be s plus 10 whole square plus 99.5 whole square. But I have to divide it 1 by 99.5. So this is a divided by s square plus a square, and this s plus 10, it will be counter by e to the power minus 10t. Okay, note down this. Definitely this is difficult question, but it is giving you so many things are included here. Done?
Yes, sir.
Okay. So now because I asked you what is qt, so qt will be Laplace inverse of fs. Okay, so Laplace inverse of this will be 1 by 99.5, this s plus 10, it will be encountered by e to the power minus 10t into, now this formula is a divided by s square plus a square, means sine 80, 99.5t. So this is your qt. See, such a beautiful question. And here, if you want to find it, so that will be dq by dt. You differentiate it, you will get that. Note down this. So this is your Laplace transform.